This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 95. We look at enhancements in Ansys HFSS 2021 R2 and review news and events from around the world. Welcome, I'm Eric Miller, one of the owners of PADT, and I'm recording this from the Air Force Academy Hampton Inn in beautiful Colorado Springs, Colorado. We are exhibiting at the Space Symposium, our second out-of-state conference. PADT is in several booths, one that we are sharing with three other Arizona companies, Freefall Aerospace, Advatech Pacific, and Qualtech. Freefall and Advatech are both Ansys users and PADT customers, which I'm happy to have them with us today, or this whole week. We're also in a booth for EOS and Flonex and in the Stratasys booth. So if you see any of us wandering around the conference, please say hi and let us know that you listened to the podcast. I want to apologize for getting this episode out late as well. Last week was busy at my house as we packed up our older son to return to the University of Utah for in-person classes, and our youngest is off as a freshman to San Diego State University. And I'll be honest, when we got back from driving the younger kid to San Diego and then back, getting him into his dorm and then moving back again, I had no energy for anything, including this podcast. So here I am in my hotel room trying to catch up before I head off to the conference this morning and talking about all things Ansys. So I apologize for being a little late. For our interview in this episode, I virtually sat down last week with Aleksandr Gafarov, one of our electromagnetic experts, to talk about what is new in HFSS 2021. Let's listen in to see what he has to share.
Welcome. Today, we are going to be talking about HFSS with our in-house expert. Aleksandr is joining us from outside of Denver today. How's it going up there?
Hi, Eric. Pretty good. A little smoky, but overall, not too bad. Not as hot as Arizona.
It's humid here right now, so we're complaining. We're just a bunch of whiny people right now because of the humidity. So
if it's too hot, you guys whining. If it's too humid, you whining.
Exactly. We all want to live in San Diego. This is as close as we can get. But what we're here to talk about today actually is HFSS and what's new, because we've got a new release. 2021 R2 came out maybe close to a month ago now, right? We'd love to hear from you what you think is cool and what users need to look at. And I guess I'll just start with that. What's the thing that got you the most excited when you started playing with release 2?
Yeah. There's quite a bit of number of features been released in last month, pretty much. I would say, well, first of all, we have to mention that HFSS always, every release, they're trying to upgrade their algorithms and the way how everything working. So it means every release gets faster and consumes less memory. So it's kind of a constant battle. So it's never been highlighted anymore because it's like, well, it's obvious. We're trying to make it faster, right?
Kind of expected at this point, yeah.
Yeah. If we see something not being improved in that way, then people usually like asking questions. So, but yeah, there's several cool features, few new features. I would say still a couple beta features. So if we're talking about SBR Plus, shooting bouncing ray, there's a few updates there happen, and actually the SBR Plus application is quite nice in the customer perspective, only because it allows a lot of different calculations to do. And basically what happens is if you have antennas and trying to see how it works in real life, real time scenario, you placing in some large objects and trying to understand how they communicate and how it looks like in terms of wave propagation sort of, and the activity for antennas. So that's what you're going to use a shooting bouncing ray for. And so a few of the improvements there, and now I'm just gonna name them and see if we need to go in depth. So one of them is now we have volumetric approach for 3D dielectrics there. Another new thing there, we have spherical wave expansion. That's a special file type. We can bring it in now. So the file type SWE, just in case anyone knows that better than what it means stands for. So then we also have the range Doppler data, which we can export into LSDyna. Yeah, I think it's LSDyna. And then we have antenna blockage for SBR Plus in hybrid mode. So, and that basically means that we can place some objects in a way of the antenna's communication and see how that affects the transmission receiving path and channel. So that's kind of a couple features. And now I'm going to move on straight into the different subject, I guess. Okay. And I'm still trying to kind of stay high level.
Yes. It's hard. I understand.
This release was actually pretty good about number of features, and every single tool has at least 3 or 4 major ones.
Wow.
So yeah, so that's why Chip says. So SBR Plus is a good one we just talked about. So antenna arrays, that is one of the most demanding topics actually throughout our customers, and we have multiple companies who always trying to figure out what to do with their arrays and how to define them properly. And so antenna arrays is one of the big topics here, and now the improvements happen in a certain areas. So one of them is the fast embedded element pattern extraction. So which means, well, it's basically just, without going into deep details, it's basically just different type of pattern extraction for the antenna arrays. And just to give the overview about antenna array, it's actually is array of antennas. That's a real straightforward definition here. So because I'm just thinking maybe it's some mechanical, folks will be listening to this one.
Exactly. What do we mean by that? Yeah.
Right. So yeah, because the first time when I heard it, I was like, first of all, I think it sounds like array of antennas. But second, is that really that straightforward?
Yeah, exactly.
So then the other option here with antenna arrays, there's improved fields efficiency actually for 3D component arrays. And 3D component arrays is this kind of same type of thing. Is basically when we try to bring antennas, we can design the antenna and make array out of that, or we can also bring 3D component, which will be antennas. So it's a very similar concept. It's just different workflows. So that's why here in improved field efficiency for that workflow specifically. So, and then we also have a custom layout and waits for array post-processing. So once you solve everything, then you go in the post-processing procedures, and that's when you have some different options to play around with. So.
Okay. So my understanding is the reason why we're doing this is that, and I see this peripherally with our customers, it seems like a lot of people are using these arrays to do these complicated antenna that point, rather than having an actual, we all think of the parabolic dish on a gimbal, right? Instead of that, we're actually using these arrays to do it. Is that correct?
So relatively true. And most of the time, people, when they refer to antenna arrays, they think about phase array antennas. Okay. So in phase array, basically, what do you how you can visualize that? Imagine, let's say, 8x8, kind of like a chessboard. Oh, actually, a chessboard. Perfect. And so then you put a little metal which can receive or transmit energy. And each of that component actually works at specific phase. Well, not phase. So they all offsets on the phase. So basically, when the whole system works, every one element of this array actually transmit or receive energy in specific phase pattern. Okay. So like in this case, it's just more constant, more accurate. You don't have just the pulses, going back and forth. You actually have kind of pretty constant, connectivity with whatever communication channel you have. So that's kind of the reason we have the arrays here. So just we can incorporate multiple antennas who work on a different, maybe even timing schedule. We can call it that.
Okay.
So just make it more stable.
Okay. Very cool.
Yeah.
Yeah, and it definitely seems to be a growth area. More and more people are using those. Yeah.
Yeah.
Cool.
That's yeah. Honestly, I think out of all the support cases I had recently for the past month, I think at least third of that was about antenna arrays in a different
Wow.
form, and all those questions came in. So,
well, I'm glad they're improving it then. Good.
Yeah, we do need that. So there are other small things, just gonna name the improvements for HFSS. So there's a how to create PEC cap for internal wave ports, and that's actually one of the interesting things because lots of new users, I guess there's also not only new, also advanced users as well, also were a little bit confused. So they were always have a misconception about the PEC cap, which is perfect electric, conductor kind of thing.
Mm-hmm.
So when you create a port and it's not touching the metal, for example, you always have to create this PEC cap, which is the conductive area for the wave port to be backed by, in order to actually keep the model running and being able to actually work properly. So and always you have to have this little cap put on manually. And so and the problem is that sometimes people just forget. They wanted to put a cap, but they get distracted, and then they forget to put a cap, and then they're like, well, all right, let's run the model, and it doesn't work. And we had a couple of customers who came to us and says, hey, my model is not working. And we're like, yeah, right here. why didn't you put the cap here? And then they're like, oh, I thought I did. Okay, great. So now that process is automated now. So it's auto creation of the PEC cap. So that kind of takes a little bit pressure from the development, from the developing engineers. So it's kind of nice. And one more kind of easy feature, although I'm pretty sure it was not easy to develop from programming, but still it was pretty easy to talk about. So it's a far field partial derivatives in the tuning. So once you do some tuning of the antennas and you're trying to basically, it's kind of like optimization process.
Okay.
So you're trying to tune certain parameters to be able to do whatever you want to do for this antennas. And so, so now you can actually do some partial derivatives in those tuning for the far field. It's only really useful for the people who does that kind of procedures and who actually care about far field patterns. So that's why I think it's small improvements, although it's kind of big in the effort areas.
Yes. Yeah.
So.
Okay.
And just maybe a couple of beta features just to kind of point them out as well. There's a few of those. And actually one of them will be perfect transition into the 3D layout if we will be, if we have time to talk about that one too. But so the first beta feature, which is nice to have. So it's, so we can always, we have DC point calculations using Q3D extractor.
Okay.
A little background on this, that Q3D extractor is more superior tool, I guess we can. Yeah, it is a tool, but in this case, we're using the engine only. So Q3D extractor has a really strong superior solution for DC point when we're solving anything. Basically, it doesn't matter PCB, antennas, anything, any structure. So DC point have better accuracy and better calculation style in a Q3D. So now it is a better feature now in HFSS. So instead of solving DC point in HFSS, which is, by the way, across the industry, it's not a secret. It's across the industry. Full wave solution, 3D EM solutions, they don't usually have really accurate calculations for DC points, only because there are limitations in physics behind this. So usually what all the companies do, including the Ansys and all the other competitors, they calculate all the way to the lowest point of frequency. It's not DC, it's not 0 hertz. It's something really, really close, maybe 10 hertz, right? They calculate that, and then they extrapolate to DC. So yeah, in this case, HFSS has this algorithm to do, but now with this beta feature, we actually trying to embark and onto calculating the DC point actually exactly. So in this case, there will be no errors in extrapolation, because sometimes we have seen models when the customer solve those things and then they get to the DC point and then it's really off, and then the question, so why is that off? And we start looking at the extrapolation patterns and it's just using the wrong method, for example. So I guess it's a little bit too much information from this little feature.
If you need that feature, it's really important. Yeah.
That's true. I like this philosophy. So, and then there's also beta feature of RF discharge simulation.
Okay.
Again, kind of niche, but at the same time, it's still important because you're looking for discharging, information, how your energy leaves your product in this case. Okay. And the last feature for HFSS, for beta feature, I would like to mention, it's enhancement of a mesh fusion, and I'm pretty sure most of the people have this already ingrained in the brain. Mesh fusion, new technology. So now it's enhanced setup and processing of that mesh fusion. Okay.
So just basic improvements to that new way of meshing in HFSS, which has been working really well for us, right? And mesh fusion's been has been a really nice enhancement, right?
That's true. Yeah. I mean, at first it was introduced, I think it was a 2101, I think, if not early, but I think it was 2101, and then. Well, with the COVID nowadays, all my dates are off.
I know. I can never remember. I just add a year to what I think it is.
Yeah, well, relatively, yes. So, but yeah, I think it was released in 2101, and it was still still beta for mesh fusion.
Yes.
And I think now, since it was beta before, so now they keep taking the notes from the customers and understanding the process and maybe certain workflows which can be improved, and then they just improve that. So I think that's why it's enhancements for mesh fusion setup and process here. And then in general, this is that feature which I'm saying that has the perfect connection with 3D layout.
Good.
If you feel like that's the good time to talk about that.
Yeah, because again, I do see some of the tech support calls, and this, the ability to read in these layouts tends to be a common thing. So yeah, definitely.
Right. Okay, that's perfect. Yeah, because that's the thing. I mean, HFSS and HFSS 3D layout. There's a reason why HFSS is in the names, in both of those names.
Yes.
So it's kind of they kind of go along together pretty well. And so mesh fusion, it's basically it's the technology for HFSS when you trying to add multiple different meshing algorithms together. I guess you're just fusing those algorithms together and letting the computer to decide which one to use in a better way for different objects in the different components. So if you have, let's say, antenna placed in some big surface or something like that, then the mesh fusion automatic algorithm will be able to figure out how to mesh, how to adaptively mesh the large object over there and the small object, and figure out what to do with all the dielectrics in between, for example, or if there's anything happening in the even smaller sizes. And in this case, it will be able to optimize the meshing. So it will be able to do faster, I guess, and less memory consumption for that. So mesh is one of the biggest things in our world, in the simulation world here. If you have the poor mesh, you're not going to get good results. And the same thing, if you want to have really, really detailed mesh, you're not going to make it fast. It will take it forever because the tiny mesh is really tough to calculate. So that's why mesh fusion was here. And and something along the same lines in HFSS 3D layout, there is a new Phi plus mesher, also beta feature, but it's a Phi plus mesher. Kind of goes with the same philosophy of trying to use multiple different mesh technologies on the objects which has multiple different application in this case, I guess.
Okay.
So I'll give an example. So if you have in 3D layout an object, which is, let's say, a piece of a PCB, printed circuit board. So it has, let's say, layered structure, 4-layer or 44 layers, doesn't matter. So you have this structure. Then you have on top IC positioned, right? IC is the integrated circuit. You have this position there, and so you have you'll need to have some sort of connection there. So you're gonna use solder balls to connect that structure of the PCB with this IC. Instead of IC, most likely you're gonna have another. Well, the IC, what it stands for, integrated circuit. Why it's that? Because you're actually integrating the multiple different circuits. So in this case, you're putting the also bond wires inside of the IC on the structure. Okay. So all together, let's come to the point of having multiple different types of things. So you have solder balls, which is spherical areas of metal. Then you have also structured layer on the PCB side of things. And then you also have the bond wires, which is kind of like I guess, well, you can call it a tube, I guess, or one of those things. So it's that structure. So, and that's the reason why we have phi mesher. Kind of goes along with philosophy of mesh fusion. So we're using this mesher to be able to mesh all these structures in different fashion, but with really good accuracy. So this is the reason why we can now process the IC on the packages, PCB with components on them, or maybe even multi-zone PCB with let's say rigid flex, because rigid flex is a different structure for PCB. Right. So that is basically it's vMesher and Mesh Fusion chip SS, both of those opening up a huge land of opportunities for antenna designer and for PCB designers. So because then now you can actually bring the whole your product, because you used to be able to only bring, let's say, PCB and solve it, but now you can bring everything you have. ICs, no problem. Bonds, wire bonds, no problem. Everything.
And I've dealt with that on the structural thermal side. I'm so glad that that's available, because you end up not being able to model things accurately, or your model's so huge you can't run it. So being able to do this approach should solve that problem in a nice way. Yeah.
Mm-hmm. Right. And plus as well, I mean, if you're thinking about in electronic world, all the components, when they're next to each other, PCB with antennas, with the ICs in a package, everything, they're really so small nowadays. You put them into one little device, like let's say your Apple Watch. So you put everything together inside of one tiny little space. So you might as well try to figure out how they all work together. And in this case, you don't have to split your models in a different tools or different solutions and understand like, oh, my IC works this way, my PCB works this way. Okay, great. Well, how about, put them together and see how they work.
Yeah, and I do blame Apple for pushing the technology on a lot of this, because they do such an amazing, and they're Ansys users, but they do such an amazing job at packaging more complicated stuff in even smaller spaces, and we have to figure out how to model it all. So I think I'm glad that they are HFSS and related product user, because it really helps. They're definitely pushing the envelope, as I think could be said of Qualcomm as well.
Exactly.
Those companies really are pushing it. Yeah.
Well, and that's a good point, because also that leads to the fact that since we're making so smaller things, now we also start thinking about the wavelength as well, right? So because higher frequency is a smaller wavelength. So if we, minimizing everything and putting them in small, tiny spaces, well, then we might as well start using the small wavelength in a high frequency mode and be able to have a communication at that level. And that's we're talking about, 5G and 6G and, everything. By the way, 6G is a thing now. I just
really? There's a new one. They just started. No.
Yeah, we're already late. The first time I remember that 6G was mentioned, it was in 2017. And it was just a concept, proven concept. People start saying stuff like that. Oh, yeah, well, let's have a meeting, talk about 6G. And now it's actually a thing because people are thinking about those frequencies and actually know the effects in there. And like, no, I don't know. It's gonna be quick and crazy, like as usual.
Yeah, that's amazing. So any changes to the user interface that are worth noting? I think it's pretty much the same, right?
Quite a bit. Everything is most likely the same. There's maybe few changes, but very minor ones.
Good. Okay.
So for example, like again, like in the ChipSS world, right? So in the ChipSS interface, new features, let's say, for exporting, range Doppler data file exporting, you just have one extra option basically. So like just very small things here and there. The only bigger things which we have is the other tools connected to ChipSS and the layout as well. Let's say OptiSlang. So it's a small change by having one extra button, but that's a huge functionality in improvement in terms of being able to bring OptiSlang into the ChipSS model and everything. Because we used to have only pretty much Optimetrics and the Designer Explorer, for example.
Right.
But now OptiSlang being a good tool available for us as well. So now there's a button which you click, and you actually gonna get a different GUI comes up, and you'll be able to set up your project within a ChipSS environment. But it will just translate all the data information into OptiSlang engine and run that on the background. So huge improvement, but only one button change.
Yeah, that is big, and if regardless of which physics tools you use, as OptiSlang gets built into more and more of them, it really is upping our optimization game. It's pretty powerful stuff. So if you haven't looked at it, you really should, because you may not be familiar with it because it really kind of came from the fluids and solid side of things, physical mechanical side of things. So
right.
Having it available now in HFSS is I think it opened a lot of doors to a lot more what if studies.
Exactly.
Optimizing that design. Yeah.
Cool. Oh, that's exactly true. Yeah.
Anything else out there worth bringing up?
Well, so that's something which I thought about. So, I mean, I have to confess, it was a little trick from my side. It's only for people who stay in all the way through this 30 minutes of the.
Okay.
So that's a benefit. If you leave early, then I'm sorry, you're not gonna.
You're gonna miss it. Yeah, exactly.
So, Ansys has actually partnered with the EMA 3D tool. And that's mostly for cable harnesses and for different discharge simulations and everything. But the thing is, also ChipSS, they introduced another, it already had this functionality about cable modeling, but now it's being enhanced and have now a slight comparison with this EMA 3D solution. And so now, technically, this is what it is. So if anyone has the cable problems or cable modeling ideas, or they just simply have a cable next to their antennas or anything, now you can generate the model and solve it within HFSS and within AMA 3D, which is technically, now I guess it's a part of a solution. So, but it's still, it has a really nice capability for people who has the cables. And so, so you can definitely bring that, into your model and solve it. So cable modeling enhancement is a still better feature, but it's big, especially considering that there is also AMA 3D in the horizon, and it's, serving as a helping or maybe even superior in certain ways tool, which Ansys also can provide. So that's something which is worth of having as a reward, I guess.
Yeah. And so our listeners may not be working on the cabling part of things, but there's probably somebody in your company that is, and you guys need to take a look at this product. I mean, it's from a company that's there in Denver, right? If I remember correctly.
That's true. Yep. I pass by their office once in a while.
so local grown to your neighborhood, and it's really powerful. And I mean, I remember actually reading in the news about a cabling mishap, a crosstalk problem with a digital system. In unfortunately, the Boeing and other folks are just struggling, and this kind of got lost in all the other problems they're having. But I just, of course, being the guy I am, they if they would use a simulation tool, I wonder if they would have had that problem.
Right, yeah. It's basically if every time you have an electronic product which has energy in it, antennas, PCB, doesn't matter, anything which has energy flow somewhere, somehow. And if you have the cable next to it, so there is a possibility of some problems, only because the cables are, have a shield. That's it's great. But sometimes the shield is not as effective as it is, or maybe in certain areas it's bent certain ways, then it still creates some sort of, enhancements of energy, and it's going to get coupling, and that's messing with the electronics. And, at this point, when we, again, same thing, when we have the little tiny, watches now, which has everything together in there.
Yes.
Even one little cable creating some little tiny energy can actually mess with things pretty well. So that's the solution you want to use to be able to find and resolve that.
For sure. And and don't even, and I of course went right to aircraft cabling, but you're right. It's even in your watch, right? It's basically a wire is basically an antenna. And if it's not shielded exactly right, you can get these issues. Yeah. Okay. Well, cool. Great addition to the end there. I always appreciate it. I always learn something a little bit new. One of these days, I'll actually understand how electromagnetics works. I don't know if you saw it. This is totally off subject, but I'll bring it up because we got a little bit of time. Did you see how they used an accelerator to turn light into matter? One of the national labs.
I heard about it. I think in LinkedIn was having a post about this, and I saw it. I was like, oh, that's interesting. That's a cool topic. But then of course I keep scrolling because
I dug into it, and I bring it up because I wonder if we need to add a new module now to HFSS to model that physics so that we can actually generate, because what I really want is that transporter from Star Trek, right? So I figure if I can turn photons into matter, I'm getting closer. So look for that.
Ansys does have America now, so it's photonics. So I think they go along with your with your ideas.
Just combine that with some high energy electromagnetics and a little bit of quantum mechanics, and maybe we've got something there. So we'll see.
Soon. I bet it will be soon. Yeah.
Something else for us to learn and share. Yes.
Right.
Well, so, you have a great rest of the week, and stay safe out there because things are getting nasty again. And we will talk to you soon about these very topics.
Well, that sounds good. So thanks, Eric, again for inviting me over here. And just as my closing note for any student who listening to us, I will say that please check out the new licensing. I guess it's pretty much a free licensing for students for HFSS, Maxwell, Q3D, iSpec, Electronics Pro itself. So yeah, lots of different things there now for students. Now you guys finally getting lucky.
Yes. It's amazing, and I think it's great. And I always forget that it's because it wasn't there for a long time. So students should definitely be using it. If you're using some code your prof wrote, tell them you're still using it, but go download HFSS.
Yep.
All right. Have a good one.
All right. Thank you.
Thanks, sir. Bye.
Bye.
Okay, so Aleksandr will be going over what we talked about and the additional items on Wednesday, 8/25 on brighttalk.com. Don't worry if you missed it. You can go back and listen to the recording and watch it as a recording. That's on brighttalk.com. And if you go there, you can search for PADT and you can find this webinar and all of our webinars on that site. And let's turn our discussion on HFSS into this episode's commercial, sort of, kind of. You may not be a user of high-frequency tools in Ansys, or maybe one of the half dozen other or so physics that Ansys now simulates, and your company may not have any experts to go to when you need simulations beyond your area of expertise. What do you do in this situation? Well, you can call PADT. We are expert users of most of the Ansys products in system-level simulation of fluid thermal systems and Flonex, and our consulting team is here to help. So reach out to info@padtinc.com or call us at 480-813-4884, and let's talk about how we can help you bring more physics into your simulations. Don't hesitate to reach out. Like I said, pretty much everything we can do. So let's take a look at the Ansys stock. It closed yesterday, August 23rd, at 357.02. So it's edged up a little bit from some recent drops, but it's still hanging out about the same place that it started for the year. So it hasn't really seen year-to-date growth that we were hoping for, but we'll see how things progress through the second half of the year. Also, there's nothing new or exciting news-wise from either PADT or Ansys, so nothing to report there. And there are some really good articles in the Ansys blog that I wanted to talk about. And as usual, I picked three. One of them that I really liked is called 3 Key Enhancements in the New Release of Ansys Twin Builder. So Twin Builder is the system-level simulation tool for virtual prototyping and things like that. And it's really come a long way in recent releases. This one talks about some new things, and the one that really caught my attention is improvements in the area of reduced order models, which of course is the foundation of this kind of simulation. But there's some other things as well. So if you are doing system level, or if you want to take a look at system level or doing virtual prototyping, twin building, take a look at the Ansys Twin Builder article in the blog, the Ansys blog, this recently in the last couple of weeks. I think they put it out. And also, please do read Shedding Light on a Shadowy Target. This is a write-up in the blog on the work that Arizona State University has been doing, the Luminosity Lab, on lunar exploration. And they've been on the podcast. We had them come on and talk about how they were using Ansys for this product, so you should be familiar with it if you're a regular listener. And you're going to read more about it on the blog and how they use Ansys. It's really cool to see these undergraduates, especially, get so much done and leverage the power of a lot of different tools, including Ansys, to get there. And the last recommendation is Simulation, Process, and Data Management Made Easier. And it's a look at the Ansys Minerva product, something we don't talk about probably as much as we should on the podcast. It's a data management tool for simulation built on an open source platform, but customized for what we do in our everyday work world. And if you're not familiar with it or you haven't looked at it in a while, this is a great article to kind of look at some of the different cool things you can do for both data management and making your processes automated or a little more streamlined or consistent. So do check that out as well at the Ansys blog, and that's at blog.ansys.com. PADT-wise, we published some more Flonex user tips, and we also put out a new video from Kang Lee, again, exploring different low-frequency electromagnetic tools in Ansys, and this one's called Magnetic Gear Optimization with Ansys Maxwell and Ansys OptiSlang. So even if you're not a Maxwell user, it's a great example of how you can use OptiSlang to connect to the Ansys product family to optimize something. So it's a great example of that tool as well. Event-wise, we've got, of course, the webinar on HFSS 2021 R2 tomorrow on 8/25. And again, you can listen to that as a recording at brighttalk.com. And that's it for August. We're done. The show is done on Thursday, and we'll close out the month and get into September. Right now, the biggest thing, we'll be putting some webinars up. We'll have our normal 2 webinars. But also, Rapid TCT is coming up, which is the big 3D printing show. And of course, it's been a long time. It was virtual last year. So PADT doesn't have a booth there, but lots of PADT folks will be wandering around. So if you see somebody in a PADT shirt and you're at Rapid TCT, say hi. And that's it. I want to thank you all for your patience in listening and to this late episode. And don't forget to subscribe to our newsletter so you can keep up to date on what's going on in the world of PADT at www.padtinc.com/opt-in. And do spread the word about the podcast. Subscribe at your standard podcast subscription service. And don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 95. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. PADT, INC.com. See you next time.